Hello children, welcome back to today's class. So in today's class, let us discuss the worksheet problems from electrostatic concepts. Okay, so let us go here. Let us move to the first problem of worksheet 1 from electrostatics. First one, electric charge is an intrinsic property, conserved, quantized, or all the above. Of course, electric charge is originated from the charged body itself. So, it belongs to the particle itself. It's not an external property. It is within the charged particle or charged body. Hence, we can say that electric charge is an intrinsic property. Okay, not an extrinsic. It is an intrinsic property. Comes within the charge. And what about the conserved? Yes, we heard that, we know that from the properties of electric charges, charge can neither be created nor destroyed, but can be transferred from one place to the other. So, one object to the other object. So, we can say that clearly charge is always conserved. Okay, according to the law of conservation of charge. Now moving to the quantized. Meaning of quantized is measurement. How much charge is present? Are we able to measure or not? Yes, of course we can measure, because we know the formula Q is equals to plus or minus NE. Q is nothing but the quantity of charge present on a body. It can be measured. If plus indicates the positive charge and minus indicates the negative charge, where N indicates the number, the total number of charged particles, and E is the charge of an electron. So, one electron, removal of one electron, 1E, addition of one electron, 1E. Okay. So, removal of one electrons becomes positive plus 1E, addition of one electron gives minus 1E. Similarly, 5 electrons, addition of 5 electrons gives the charge as minus 5 ME, or removal of 5 electrons gives a plus 5E. Like that, the number of electrons transferred, based on that we can measure the quantity of charge present on a given body using the formula Q equals to NE. Hence, very clearly we can say that charge is quantized. So, electric charge is an intrinsic property within the body, comes within the body, conserved from the law of conservation of charge, and also quantized. Hence, all the statements are true. So, clearly, all the above statements are true. Okay. Now, moving to the next question. Charging by friction is used for. So, we know that the three methods of charging are done. One is by method of friction, the method is by the induction, and the other is by the method of conduction. So, all about friction is nothing but when a body is rubbed against the other body, the charges will get transferred from one body to the other body. Okay. But if you consider the metals as well as non-metals, metals, inside the metal also the charge can be accumulated. Whereas for non-metal, this lies only on the surface of the body. Okay. So, within the body and on the body makes a difference. Okay. So, inside a non-conducting, so if you consider a non-conducting material, non-conducting, other is nothing but your non-metal. If you consider a non-conducting or a non-metal, we observe that charge always resides on the surface, resides only on the surface. Whereas if you consider a conducting body means a metallic body, then we see that for a metal, even the charge can be accumulated inside also. So, both inside as well as outside. So, distributed completely, entirely. So, for a conducting or a metallic body, the charge is distributed entire the conducting body. Whereas, for a non-conducting or a non-metallic body, charge only resides on the surface of the body. Hence, So to remove or addition of charges by the method of friction, we can easily remove the charges which present on the surface of the body. So charging by friction is possible for a non-metallic surfaces rather than the metallic surfaces. Hence, is used generally for non-metallic surfaces, non-metals. The concept is clear, children? Can be easily removed or added, which only resides on the surface. From the inside, it is little impossible to remove the electrons from inside. Okay. There are other methods to remove the charges from metals. Moving to the third one, charging by induction. What is that, children? Charging by induction leads to induction. So earlier we have studied that induction means two bodies are not kept in contact. Charging a body while one body we have to consider uncharged body. This is an uncharged body, and nearby another body should be kept, some charged body, such a way that they both are not kept in contact. This method is called as your induction. So in a charged uncharged body, we observe that always equal number of positive as well as negative charges are present. Due to the method of induction, due to attraction, all the negative charges will shift towards the charged body, and due to repulsion, all the positive charges will shift away from this. And whenever it is being earth, negative electrons move from earth to the body and such that they get nullified and only negative charges being present. For an example, I have considered. Okay. So, by this method, we observe that after a while, all the electrons gets accumulated here and all the protons get accumulated here. Whenever it is being grounded, then electrons from the ground moves inside the charge and then they will get nullified. They will get nullified, something like this. Okay, they get neutralized by leaving the negative charge on the body. Okay, so by the method of induction, when a positively charged body is kept near an uncharged body, we observe that an opposite charge is induced in the uncharged body. This is an uncharged body and here now it is a negatively charged body. So when we brought a positively charged body, negative charge is induced inside the uncharged body. So during this, what happens? This is negative and this is positive. Between the two, what happens? Attraction or repulsion will take place. No doubt between a positive charged body and now the newly formed negatively charged body, attraction takes place. So, charging by induction leads to attraction. Charging by induction leads to attraction. Well, now moving to the next question, fourth one. A charge interact with another charge through. So, one charge and another charge. How do they interact with each other? So, one charge interacts with another charge because of the some positive charge is there. Around it, electric field is there. So, electric field means up to which its influence is being felt. So, if you take another charge nearby to this, another charge if you carry nearer to this, somewhere here, then whenever a charge is brought in the area of electric field of the first charge, then what happens? Some interaction may take place, maybe attraction or maybe repulsion. If it happens to be the same type of like charges means repulsion takes place. And similarly, if you bring opposite charge, attraction takes place. So how this interaction? Interaction means either the attraction or repulsion. So, okay. So charge interaction with another charge through electric field. So the electric field will decide whether to attract the other charge or to repel the other charge. Hence, the correct option is option A, electric field. Okay. So now moving to the next question, that is fifth question. When a charged body and uncharged body are brought in contact, charged body and uncharged body are brought in contact at equilibrium, then what happens? Their charge is equal, their field is equal, their potential is equal, and their potential energy is equal. So, when two charges, uncharged and uncharged, both are brought equal and they kept in equilibrium. Equilibrium means balanced condition, equal number of charges. Okay. So, suppose if it consists of 5 coulombs of negative charge, the other consists of 5 coulomb of positive charge. That means equal number of charge. Okay. Then, what is said to be equal means they are maintained at equal potential. Their potential remains equal. Okay. Well, in which of the following methods of charging there is actual contact between the bodies? So, what are the methods where the actual contact is? So, we have 3 methods of charging. One is the method of friction, the other is method of induction, and the other is method of conduction. So, we observe that in the 2 cases, method of friction, 2 bodies will bring in contact. Method of induction, both are kept apart from each other. Method of conduction, both are kept in contact with each other. So, in the method of conduction as well as the method of friction, 2 bodies must be kept in contact with each other. Hence, charging by friction as well as charging by conduction. So, both the charges are kept in contact with each other. Hence, the correct option is both the statements, that is A and C. So, now moving to the next one, 7th question. A soap bubble is given a negative charge. Soap bubble is given a negative charge. Then its radius. So, consider a soap bubble. So, for this soap bubble, what charge is given? Negative charge is given. So, what happens? All are same charges, like charges. We know from the property of charge, like charges repel each other. So, due to the tendency that like charges repel each other, all the electrons tries to move away from each other. Inside the soap bubble, all the electrons tries to move away from each other. So, whenever they move away from each other, it has a tendency to expand. The soap bubble increases, soap bubble increases its size due to the expansion, because the electrons will move away from each other. So, as a result, its radius increases. Its radius R1, R2, R2 is clearly greater than R1. Clear, children? So, what is the correct option? A soap bubble is given a negative charge, then its radius